Okay, sorry, HoverCam froze. This is section 7.2, key solutions to the homework. I'm sorry, a little flustered because my HoverCam stopped in the middle, and I don't want to redo everything, so I'm going to pick up right here at number 6. I'll post 2 solutions for this, or 2 videos for the solutions. All right, PQ is the diameter of circle O. P is at negative 317 and Q is at 5,2. Find the coordinates of the center of circle O. Uh-oh. Uh-oh. All right, well, let's just kind of figure out. So negative 317. So negative 317. So let's put P up here. And Q is at 5,2. 5,2. I put it way down here because we know it's a diameter. I don't know exactly where the x and y axes are. That's okay. And we want to find coordinates of the center. Well, the center is the midpoint of the endpoints of the diameter. So all we need to do is to find the midpoint between these two guys. So remember, for midpoint, we're going to find the average of the x's and average of the y's. So we add up the x's, negative 3 plus 5, and divide it by 2. Add up the y's, 17 plus 2, divide by 2. Let's see, negative 3 plus 5 is 2, divided by 2 is 1. 17 plus 2 is 19 divided by 2, you could leave it as 19 over 2, or you could write that as 9.5. There's your center. Number 7. Okay, find the radius of circle P. So, all right, we have circle P is tangent, or just touches the x-axis. Point P is at 1513. Q is at 1916. We need to find the radius of circle P. Oh boy. Well, normally we say draw the radius to the endpoint of the chord, but that's not really going to help us in this particular case. I want you to think about this radius going right down here. Isn't that a radius? Going from the center to right here? Well, that circle touches the x-axis, so this distance is the radius. How far up is that point P? It's up 13 units. So the radius of circle P is 13. Okay, now let's find PQ. We're going to have to use the distance formula here. So distance formula is big square root, subtract the x's, so 19 minus 15, square it, add on, subtract the y's, 16 minus 13, square those. All right, let's see what we have here. 19 minus 15 is 4. 4 squared plus 16 minus 13 is 3. 3 squared. Square root of 16 plus 9. Square root of 25, which is 5. So PQ is 5. All right, now we want to find the length of segment AB. So now go back and draw your radius to the end of the chord. What did we say the radius was? 13. Look at this triangle right up here. That's a 5, 12, 13. 5 and a 13, that's 12. So if this piece right here, AQ is 12, then AB is 24. Good deal. All right, number 8 is kind of tough. So I gave you some instructions over here on the side to see if I can help you through this. So let's label first. PQ is 4. RQ is 10. PO, all of that is 15. And I want you to find PS. Okay. So first thing, let's answer these questions. How long is TQ? From T to Q. Well, R to Q is 10, so T to Q must be just 5. How long is TP? 5, 4, 9. All right, let's use triangle TPO. 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 I'm going to redraw that down here or over to the side so we can do this. So here's this triangle. Triangle TPO. And here's what we have. This much is 9. PO is 15. We're going to use this triangle to find TO. Okay. Let's see, if I divide by 3, it's going to make this a 5, 3, oh yes, 4. 3, 4, 5. We divided by 3, so that makes this one back a 12. So TO now is 12. Okay. Draw radius OQ. All right. Draw radius OQ. Got it. Use triangle OTQ to find the length of OQ. OTQ. So I'm going to color that in. OTQ. OTQ. This triangle, this little bitty green one. To find the length of OQ. Oh, yes. OQ. Oh, yes. 13. That's a triple. 5, 12, 13. To find the length of OQ. 13. Score. All right, now how long is OS? Well, if OQ is 13, OS is also 13 because they're both radii. Now we can find PS because PO is 15. OS is 13, so PS is 2. Yes. Nice. That was fun. I like the steps, though. I think the steps help. All right, let's look at this last problem here. 2 circles intersect and have a common chord of 48 millimeters. So let's put that in. Common chord, 48 millimeters. The radius of the smaller circle is 26 millimeters. And the distance between their centers is 28 millimeters. Radius of the smaller circle is 26. Radius of the smaller circle is 26. Common chord is 48, so the top half is 24. All right, let's look at this triangle right here. I'm going to come draw it over on the side. Sometimes it helps to draw those triangles off to the side. So we have 24, 26. I'm going to divide out by 2. Makes this a 12, 13. Score. 5. Multiplied back by 2 makes that piece 10. So this as much as 10. Okay, what are you trying to do still? Oh, find the radius of the bigger circle. So I'm going to go over here and draw the radius of the bigger circle. I'm going to take this triangle and pull that one over to the side. All right, this 24. Now this piece down here, this bottom piece, we can figure out. The whole thing, the distance between the centers was 28. That much is 10, so that means this piece over here has to be 18. Okay, let's divide out by 6. 3, 4, again. 3, 4, 5, multiply that by 6, 30. So the radius of the other circle is 30 millimeters. Thank you. Hope this helped. Bye now.